Today I'm going to be giving a very brief talk on leveraging Python for multi-dimensional data, visualization, and anomaly detection. Um, it's a privilege to be with you guys here today, and I hope that we can learn a lot. This is actually very basic stuff. For those people that are interested in getting into data analytics, this is like beginner stuff. So some people might, I already know this and stuff like that. It's fine. But for a lot of people that are just venturing into data analysis, data analytics, this will be very beneficial for you. So, before we proceed, let me do a brief introduction of myself. Okay. So, a brief introduction for myself. Ezinwanne Aka. I am a data scientist and an AI engineer. As a data scientist, most of my work revolves around health and geospatial analysis. As an AI engineer, most of my work revolves around computer vision and natural language processing. I'm the senior data scientist at Data Lab Analytics. We're a consultancy, product development, and training organization. I have over 6 years experience in various aspects of the data ecosystem. I started out as a data analyst, then I became a business analyst, then moved on to a data scientist and a machine learning engineer and AI engineer. So I've had experience in several aspects in the ecosystem. I'm also a Kego X BIPOC mentor, and that is for the Black and indigenous people um, communities, mentorship for them getting into data science. In my first talk, um, on the first day of the conference, I mentioned that it is a very important, for those people getting into data science, it is going to be very important for you to be part of this program. I am a mentor there, and they are looking for people like us. So it's basically for Black people and people of indigenous communities to be able to introduce them into data science. And for many of the people that are part of that community, especially the mentees, you also get grants and the rest. I know as of last year, many of the mentees got at least $1,000 as grants for them while they were doing the program. So I will encourage us to be part of it. It's really very, very um, beneficial. So I love building and driving decision making using data. So that's basically me. If anything that involves building something new, if it's anything that involves driving decision making using data, then I'll probably be involved in it. So that's that about me. I'm not that interesting. Let's go to the meeting while we are here. So data visualization, and because this is pretty much basic, I'm just going to be starting from the basics. And why is visualization important? And before I go into that, I might want to talk briefly about why I even thought about this talk. We are working on an in-house project in the office. It involves electricity data in Nigeria. We are trying to see how we can create systems that can predict outages. We can create systems that can help people manage their electricity consumption and usage better. And one of the things that we found out doing that is that a lot of people find it difficult to pass across data that is multidimensional in its context. For example, you have maybe a univariate data or a bivariate data. People can analyze that very quickly, share information with stakeholders. But when we want to pass information across to stakeholders, because with stakeholders, visualization is very important. You don't go to a stakeholder and be telling him the mean deviation from the this. He doesn't know what you're talking about. But with things like visualization, you can easily pass it across. And we found out that there was a very big gap. A lot of people in the data science space didn't know how to present data that were multidimensional in nature. And also we found out that understanding how anomaly works, something that is outside the normal, was very critical. And that's what this talk came about. So why is data visualization important? It is a critical tool in analysis. It transforms complex dimensional data into graphical representation, making it easier to understand patterns, trends, outliers. Now, those are some of the key things you have to take note of. When you're visualizing data, when you're carrying out any analysis, there are some key things you should take note of. Patterns, trends, and what? Outliers. Those are some of the important things that you always take note of. Another reason why, on a side note, why I find this very interesting for us to do is because of the fact that if you go online in social media, there are some people that they are, what they call them, tech influencers. I don't know whether you have seen some of those ones. Those kind of people that say, learn Python in 2 weeks, get a job paying $100,000 per month in 2 months. Yes, learn Django in 5 days, and those kind of crazy people. So, and there was a day one of them said something, and he said something like 90% of data analyst work doesn't involve statistics. And I sat down, I thought about it. And normally, when I see stuff like that, whether it's on Twitter or I just scroll by but for him to say 90%, and I was like, what do you mean by that? And he was now saying, data analyst work is just to do pie chart and do a bar chart. And I was like, it shows to a very large extent that people do not know what is involved in data analysis or in data science. And that is why, even for you to carry out visualizations like we're talking about today, you need to understand the statistics behind it, because that is what will give it interpretability. You will not be able to interpret what you're showing if you do not understand the statistics behind it. So, trends, pattern, outliers. Visualization enhances comprehension for quicker understanding. Compared to raw numbers, it facilitates communication. Representation of data can be more effective when you're communicating it through charts and graphs and visualizations, and it helps in decision making. There was one of the speakers yesterday that was talking about an organization. It was the guy that was talking about streaming data with a database. I can't remember the name of the database now. It was a very nice presentation. Yeah, thank you very much. And one of the things he said is that, for example, you work in an organization and they can build 1,000, they'll tell you that, oh, we have built 1,000 dashboards in this organization. But if you check it, nobody's monitoring any of those 1,000 dashboards, because it's not passing across any information that is helping the organization. They're just building it because they can build. And you don't just build because you can build. There has to be something behind it. And the main thing behind everything that data analysts and data scientists do is to effect decision making. So when you build something, you look at it. Is it going to help make a decision? Is it going to help make a conclusion? Or is it just beautiful? A lot of people are just focused on the beauty. Let me get something that is aesthetically pleasing and nice and good to look at. And it was something that, for example, I see a lot of people online. They say, oh, I just started data analyst and this is the dashboard I built and stuff. And when time I go through some of those things, I just see that they are nice. It's more like if I'm to describe it, I would say it's more like a UI UX kind of design, in the sense. Like it doesn't pass across any information, but it's just beautiful. You see it and be like, wow, wonderful. But there is no information that you're getting from it. And that is what the business needs. They don't need the beauty. In fact, there was a project I worked on a while ago. He wanted to build a pipeline from his Google Analytics to be able to analyze the website's data and stuff like that. And by the time I built the dashboard and everything, because there was a deadline and he needed it to be up as quickly as possible. And I told him that, it's not as if I've not done it though. I've done, when you're building stuff like that, you want to get like an MVP, a minimum viable product. And I was like, I've done that part. The dashboard is up, but I want to still put some, in our colloquial used to say some serene, some paparazzi, like make it a bit finer and stuff like that. And he was like, let me just see what you have done. And I sent it to him and he was like, oh, no, this is fine. I don't need, I'm getting the information I want and everything. I was like, he said, no. As far as it's working, I'm getting the information I want. That's cool. And that showed me to a very large extent that some of those things that we pay attention to, those serene, for a lack of a better word, those aesthetic stuffs might not be as important, are definitely not as important as being able to transform or pass across the information effectively. So, Next slide, please. So, data visualization for insights. So, data visualization can provide a wide array of insights, and these insights are key. These are some of the key insights that you should be looking out for when you're trying to visualize data. You're trying to look at trends over time, how things are changing over time. Very important, and that's where you'll be doing things like time series analysis and the rest. And in those kind of stuff, you're looking for trends, you're looking for patterns, you're looking for deviations from patterns. So you're looking for trends, the general movements, seasonality, reoccurring patterns, and deviations from patterns. For example, if I take the rate of naira to dollar over the last 3 years and I plot it on a chart, the trend will be generally what? Upwards, isn't it? Even though there are some times that there was a drop and stuff, but the trend will be generally be what? Upwards. That's trend. And there is what we call seasonality. So there are some times that some things repeat themselves over and over again. And somebody might be wondering, why is that important? And that is because as a data scientist or a data analyst, when you are carrying out your analysis, it is very important to know that the description is not where your work stops. Many people think that descriptive analysis is where everything ends, but that's actually just the beginning. It's like you go to a doctor or you go to a pharmacy. In Nigeria, we normally go to pharmacist, and you say, oh, the doctor will tell you, describe what's wrong with you, right? And you say, oh, I'm having head pain, I'm having a stomach pain. That's descriptive analysis. So you're trying to describe what is wrong with you. But there is a next step, because if you just describe what is wrong with you and the doctor was like, oh, nice, you can leave. He have not done anything for you. But there is a next step called diagnostic. So why is that thing happening? It's not just that you have described what is happening, but why is it happening? So for example, if you have looked at trend over time, you have seen deviations from pattern, then you want to know why those deviations are happening. If it's a positive deviation, you want to know whether you can replicate it. Because if you know why it happened, it means that you can replicate it. If you don't know why it happened, then it means that you're leaving it to chance. If it happens again, good. If it doesn't happen again. So if it is something bad that happened, or maybe there was a drop in sales, by understanding why that deviation happened, you'll also be able to avoid it in the future. So one of the things we always look for, trends over time, comparisons, comparing different groups or categories. Use things like your bar charts and the rest for that. Correlations, trying to understand the relationship between different variables, how this is related with that. And there's a very popular saying, I know that most of you are always familiar with it. Correlation is not what? Correlation is not what? Causation. And the only way you can be definitely sure that a correlation is not causation is by going further into diagnostic and not just what you can see. Because once you have found a correlation, you say, oh, that's cool. This is highly correlated with this. But the diagnostic part is knowing what caused it, and that's the causation. Very, very important. So the next thing you're going to, you will normally see in visualization is insight and distribution, and that is the distribution of data points. For example, you want to look at age groups. For example, I take everybody's, the age of everybody in this hall, and I kind of plot a distribution to know how the ages of people here are distributed. And I believe in this hall, the ages should be close to a normal distribution, if I'm not mistaken. We'll probably have fewer people at the younger ages, more people between, let's say, 30 to 50. Then we'll still have some elders that are above 50, and so fewer of them. So it'll be more like that. So when you want to show how spread apart the distribution of your data is, and that's also very good information when you're carrying out analysis. So outliers and anomalies, I'll still come to this later on, but it's very important to be able to know when something is an outlier or something that is different from what is expected. That is an anomaly. You have what is normal, and you want to look something that is different from the normal. Proportions and ratios, showing how parts contribute to a whole. And I not even, most times when you want to show that, not even this chart might even be better. You probably want to use something like a pie chart if you want to show how a part contributes to the whole. Because one thing about visualization is that I can use the same data points to pass across different informations using different charts. The same data points, the same data, not different, but depending on what I want you to see is depending on what visualization I will use. So for example, I have the data of the profits made by different companies in 2023. If I want to just show you how much profits each company made, I'll probably use something like a bar chart. So you can see this company made 20 billion, this company made 10 billion. But if I want to show you what percentage of the total profit made from that industry by that company, I'm going to use something maybe like a pie chart, because I want to show you how the parts contributes to the whole. So that's something you have to also understand. So progress and performance ranking, clustering, and the rest, I'm just going to be moving pretty quick. So there are some challenges that happens when you're visualizing multidimensional data. We'll get to that, like complexity, because in the multidimensional, most of the ones I showed you earlier is either univariate or bivariate. So you're just looking with one variable or two variables. But when you're coming to analyze multiple variables at the same time, then you're going to be having issues with complexity and interpretability. So those are two of the major things. So it's harder to derive meaning and insights from that. So I'm just going to be giving a few examples of some visualization. And by the way, I'm going to put it, so I will encourage all of you to join the PyCon Slack channel, because I'm going to put the GitHub on the GitHub, the link to the code for some of the visualizations that were done here for multidimensional analysis. So these are some Python libraries that can help you for multidimensional visualization. I believe everybody's familiar with them: Matplotlib, Seaborn, and Plotly. My personal favorite is that last guy there. Plotly is my personal favorite. Yeah, so that's my favorite. So let's look at some techniques. So this is scatter metrics. So effective for identifying correlations and clusters in data sets with moderate number of dimensions. You don't have so many dimensions. This is also very good for multivariate analysis. We have this kind of heat map. This is actually electricity data. This is actually real electricity data. On the y-axis, you have days. On the x-axis, you have time of day. And you can see some things happening here. And who can give me an idea of what you think is happening here? On the y-axis, you have like the days or the year, so the first, the second, the third, to the 30th of the month. On the x-axis, you have the time from 12 to 1 a.m. to 2 a.m. for the 24 hours. So who can give me an idea? What do you think is happening here? Who can give me something that he sees from this chart? Yeah, generally, what you can see, thank you very much, from this point, which is 8:30 to 3, this person uses energy at a very high frequency. Like, his consumption is very high. So this generally is his peak period usage. Can we get that from this chart? So you can see it from the chart very clearly. So, but if somebody was trying to look at time, days, and electricity usage, those are 3 variables. You might find it difficult to plot. But with this now, I can easily tell you that, oh, generally, this is this person's peak usage. Oh, he uses energy from this time to this time. This is normally when he's sleeping. There are some people that are like me, that are nights. We prefer to work. We prefer to work at night. So our own map will probably be something quite different. So our usage of electricity will probably spike up to during the night time. During the daytime, to be like there are ghosts in the houses or something. So radar charts are also very good for multidimensional visualization. I just plotted this simple one using Plotly. For those that are football enthusiasts, this kind of chart will not be strange. Will not be strange to you guys. Like, for example, you are comparing the attributes of 2 different players, KDB and Cole Palmer. So we are comparing the attributes of those 2 players, so you can see defending speed. So we have several variables for those 2 players. So for us to be able to compare those things, there are limited charts that can help us to be able to compare that. But radar charts is very good. I don't know, do you all agree with this chart? Defending. They say Palmer is better than KDB. Is that true? Let's see. Team play, okay. Who is higher in team play? KDB. Who is more technical? KDB. Okay, but Palmer has more speed. Okay. Do we all agree with that? Or does anybody disagree with that? You disagree. So moving on. This is also a 3D graph is also good for visualizing 3D scatter plots for visualizing multidimensional data. Very, very useful. Like you can rotate around it. Although it will require a bit of, should I say, understanding of how it works to be able to interpret it. It might not be easy for people that are not into it to be able to interpret it as much. So, this is another one. This is a very nice one also. You can see we have the days. You can see base usage. So electricity usage. So at any point in time, this is what the person used. You can see the blue indicates what he uses in the morning. This is what he uses in different times of the day. So you can use a combination of charts to visualize multidimensional data. So you can combine different kind of plots together, but let it not be confusing. But this one is something that you can clearly understand. So I'll quickly rush into anomaly detection. And that is a crucial aspect of data analysis that involves identifying data points that deviate significantly from the normal. And when something deviates significantly from the normal, it is usually referred to as an anomaly. And it is something that we in data analysis or data science see a lot of. Now, these outliers can provide critical insight for a variety of applications. I remember for most people that get into data analysis or data science, there's normally one data set that most people start with. Anybody? Titanic, right? Good. Titanic data set. And I can remember one day I gave some people a project. An Irish data set through. And I gave some people some projects to do some analysis on data set and stuff like that. And while they were trying to clean up the data, because of their general knowledge about data cleaning, they just got to where there were outliers and they just removed the outliers in the price of the data set. And I was like, do you know that that outlier can give you information about that data? And they were like, how? So what I did is that I extracted the data points that reflected that outlier in the price. And I found out that I could track the places because the tickets for the Titanic were bought at different ports. And the data, if you see it in the data, you can see where the people bought their tickets from or they loaded from. I could actually track the ports that were, should I say, inflating the prices of their tickets. You could track it because when you see the outliers, the ones that are outside the normal price range, then based on that, I could able to track it and say, oh, all these ports that had for first class double the price, they bought from the Portsmouth region, and this one bought from this region. And that is what outlier analysis does. So please, as data analysts, don't always just, you get outliers, you say, you do away with all of them. They also hold very important information. Very useful for fraud detection. I've personally worked on something as regarding network security, detecting network intrusion using machine learning. So this is an example of a chart from anomaly detection. This is from energy usage, and you can see that there are some points which are exceedingly high or exceedingly low. So process for anomaly detection, you normally want to first of all define what is a normal behavior, because before you know what is abnormal, you have to know what is what? Normal. Before you know what's abnormal, you have to know what's normal. So after that, you want to detect deviations or analyze new observations. You want to evaluate and iteratively improve on the model. And finally, you want to investigate those anomalies. Know why those anomalies are happening, whether they are randomly happening or whether there is a pattern to them. Remember what I said about patterns. If you discover the pattern to something, then it means that it can be replicated. If the pattern is not discovered, then it means it's happening randomly. So that is something we always look out for. So there are some anomaly detection methods. We have the IQR method using the basic interquartile range, Q3 minus Q1, the statistics, this thing. So the ones below the Q1 and the ones above using the IQR times 1.5 and the rest. I believe for those people in statistics, that will not be strange to you. We also have the isolation forest. The isolation forest kind of just um, uses a method of trees and trying to recursively goes through the different data points and tries to group them based on different characteristics. And after a certain times, the one that belongs to the smallest group is known as the outliers or the anomalies. So that is that. And we have local outlier factor, one class SVM, and auto encoders. Those are also very...
Time up.
Okay, yes. So applications, financial sector, fraud detection, and the rest. So in conclusion, we can leverage Python for multiple analysis and anomaly decision. So thank you very much. I believe that we have learned a thing or two. Like I said, this is mainly beginner stuff, but I believe that we are able to learn something. Thank you.
Thank you.